ladies and gentlemen, a little post-work afternoon coding session. We're gonna go ahead and go straight into day 6 of Advent of Code. Did some boilerplate stuff there. Kind of exciting. We're getting to see a little bit of these ASCII art pictures going on here, and so that's exciting. So day 6. Let's see how this goes. Tuning treble. The preparations are finally complete. You and the elves leave camp on foot and begin to make your way toward the Starfruit Grove. As you move through the dense undergrowth, one of the elves gives you a handheld device. He says that it has many fancy features, but the most important one to set up right now is the communication system. He's heard you have significant experience dealing with signal-based systems. He convinced the other elves that it would be okay to give you their one malfunctioning device. Surely, you'll have no problem fixing it. As if inspired by comedic timing, the device emits a few colorful sparks. To be able to communicate with the elves, the device needs to lock onto their signal. The signal is a series of seemingly random characters that a device receives one at a time. To fix the communication system, you need to add a subroutine to your device that detects a start of packet marker in the data stream. In the protocol being used by the elves, the start of packet is indicated by a sequence of 4 characters that are all different. The device will send you your subroutine, a data stream buffer, your puzzle input. Your subroutine needs to identify the first position where the 4 most recently received characters were all different. Specifically, it needs to report the number of characters from the beginning of the buffer to the end of the first such 4 character markers. For example, suppose you receive the following data stream buffer. After the first 3 characters, MJQ, have been received, there haven't been enough characters. So we really just got to start with this. And based on the previous rule, there's 2 J's because the J is repeated. This isn't a marker. Okay, cool. So we can essentially scan 4 characters at a time. What's interesting is, So at first glance, we could just scan. But if we scan and we have 2 overlapping characters, we can actually jump ahead because we know that J and J, we know that we can move 1 character position of the character matched. So then we can move straight to here. Sorry, I'm thinking about over optimizing this already. So essentially we're going to look at a 4 character window. 1, 2, 3, that has all unique characters in it. So as you can see here, if we kind of follow this pattern, I'm sure they've already revealed it to us. There isn't any marker. The first time a marker appears, the 7th character arrives. So that's 1, 2, 3, 4, 5, 6, 7th character. So boom there, which are all different. In this case, your subroutine reports 7 because the first start of the packet mark is complete after 7. But as we can see here, JQPM, the 7th character is the M, so that's the last character of the 4 character string. I haven't looked at the output yet, but I think optimization is going to need to be key here. But we can do some tricks to figure out how far we need to go in different scenarios. But we get to the 7th character and we can report that. And so here's a couple other examples. 1, 2, 3, 4. So these are just integers, and these are specifically on the start of packet marker. So sounds pretty good. We've got a couple of good examples. We can start with this one, which is 7. And so let's get into the code. We're not going to call it test.aoc. We're going to call test start of packet marker. And we're going to create a method for that. And our expected is going to be an int. So there's some boilerplate from the previous one. And our input's going to be a string. And we know our expected in this case is a 7. And our input is simply going to be that. And let's go ahead and create the other 3 examples. So we've got, this is 5. We've got, this is 6. This is 10. the last one is 11. Okay, so we get all of our things in here. We've got expected and actual. So our actual is going to be our test.input and on a function called start a packet marker. So start of packet marker. Okay. And we're going to create a function called which takes in a string and returns an int. So that's going to be the character, not the index, but we can pretty much do index manipulation. All right, so we're just gonna do a for loop here. So we're gonna say for I is assigned 0, I is less than minus 4. I don't like the string. So we're going to be going starting at I index 0, and we're going to be going plus 3 of that. So 0, index 1, index 2, index 3. And that's going to be the slice. We are back. I had to take, it's been kind of close to 12 hours in that little break. You know, when you have a family and other priorities, other things come up. And that's okay. But let's get back to the problem. So we created our test and we've got the start of packet marker method. I think it's that. And our input is a string. I don't know why that got capitalized, but test.input. Okay. So we got to work on this start a packet. So I started creating this for loop and I was very forward thinking, but I think we can think backwards. So instead we start at index 3. So we get 0, 1, 2, and 3. And then we just need to end at length minus 1, which will give us the end position. And then we're always going to look backwards from I. Now there's a couple different ways we could do this. If we've got an array and we're starting here and we know that our packet size, I don't know why I put spaces, probably just for visualization, but we know that we want to check these things, these other things. And so the way we do that depends. So we can start at index 3, and then we can say, is the letter on index 3 in index 2? Is it also in index 1? Or is it also in index 0? And if those all fail, if there is no match, then we can go back one index, index 2, and say, is this character in index 1 or index 0? We already know it's not in index 3 because we checked that initially. And if none of those match, then we can just simply say, is index 2 and index 1. I feel like that's probably the more efficient way to do it. That's what I'm going to do. And then once we figure out if none of these match, then we return that number plus 1. Because remember, it's not the index, but it's the count position that we want to return. So we're going to do this. This will iterate us through the array or the slice. And then so we could just simply say, oh, we could also take some shortcuts. We could also just create a unique set. And then we can see if the unique set, the length of the set is equal to 4. And if it's not, then we know that there is a duplicate. So all I should need to do is if sub of I equal to sub of I minus 1, or sub of I equal sub of I minus 2, or sub of I equals sub of I minus 3. So that'll put us at, if we were at 3, this will compare it against index 2, this will compare it against index 1, and this will compare it against index 0. So if any of those match, we return I plus 1. Okay, so that should be either. And then, we just need to do our other 2 checks. This is a bit barbaric, but I feel like it'll give us better efficiency. Let me change. Yeah, the one problem with this solution is that it's not going to scale. And positive, I'm not really sure what's going to come next, but doing it this brute force, you're going to end up having, if the number changes like we saw last time where it went from a reverse to non-reverse, and in this case they decide, oh, it's not going to be 4 characters, it's going to be 5 characters, it's not going to scale. So then we can think about looping, or we can think about other options. I think what I want to do here, the solution that I was proposing is we would just get rid of this. I would actually get rid of this. So this is the not so great way to do it. It works. I mean, don't get me wrong. But then where are we at with scale, right? So, okay, let's just test it. So this works. Boom. Oh, what did I do wrong? Oh. Okay. That's not needed for this or this. Okay. Expected 7, actual 4. These are not returns because that's when we get a match. We want to continue to the next iteration, and only if we don't get a match do we return I plus 1. Okay. Sorry about that. That's passed. Okay, so I think this actually solves our initial problem. I have a feeling that's not going to be the right approach, but we're going to just kind of go with it. So here we'll call AOC start a packet marker S. AOC is int in this case, and %d here. So if we run this, go run, we got to add day 6. All right, let's put our day 1 text in place. Our day 6-1, and that'll be from the input. So let's get the puzzle input. There we go. To part 2. Oh, see, knew it was coming. 14 distinct characters. Let me read this out. Part 2. Your device's communication system is correctly detecting packets, but still isn't working. It looks like it also needs to look for a message. A start of message marker is just like a start of packet marker, except it consists of 14 distinct characters rather than 4. Here are a few first positions to start a message markers for all of the above examples. How many characters need to be processed before the first start of message marker is detected? So are these inputs the same as my previous test? Hope so. That makes things pretty easy. We'll just copy these out of here. Yes. I'll just put them right here. And we'll call this to start of message. Message marker. We've got 19, 23, 23, 29, 26. I called it packer instead of packet. Whoopsie. Fix that. Store to packer marker. Okay, that's right. Okay, so this now is archaic and unrealistic. We could get like a length and then kind of loop backwards and check every character. That's one option. But I think we're kind of getting to a point of scale where that doesn't really make a ton of sense. Let me just fix this. It could work, but I think there's a different approach I want to take, which is simply to create a unique set from my string and then check to see if that length of that is... There's one other thought here, which is we can make this more efficient because let's just solve and then we'll talk about a more efficient approach. So there's this library that I've been looking at called Lowdash, or Low, I think. It's based on, there's a JavaScript library called Lowdash. And so I want to try implementing this because it has a unique method on it. And so we're going to try that. And so we're going to bring this in. And then I want to use, so the only thing is you have to use byte arrays, but that's not, that's not a huge issue. In fact, I'm going to change this to, I'm just going to remove this. This doesn't make any sense really. And we already have a byte, so we're going to do start a message here, and we're just going to send in those bytes. This will be easier. So boot. All right, so we're just gonna do that. So we'll modify our test real quick. Our input is going to be a slice of bytes, and then I think the way we can just handle that is it this? It should be that right there. Okay. All right. So bytes. Okay, cool. So now with this set of input, the reason I wanted to use this library, the reason why I have to use bytes is because you have to use an array. We know the startup packet marker is 14. So we're going to do something similar here where we're going to start at 14 and we're going to go to the length of B, but we're not going to grab all of B. We're going to start at 14. So I'm going to just use a const start of packet message marker length, which is equal to 14. And who knows, this might come in handy later. 14. Okay, perfect. So we're going to start at 0 to 14. And so what we're going to do is we just need to get a unique set. Now, this is less efficient. This is not the most efficient way to approach this, and then we'll talk about a more efficient way to approach it. But let's just get the problem solved. So what I need to do is, so low dot sort, or unique, I'm sorry. I think I need to Let's go ahead and get that package imported. Boom. Okay, so unique. Collection T. So we're going to use our byte array, and we're going to go from and message marker length -1. Yeah. So we don't want I to be 14. We want it to be 13 because we're dealing with zero-based indexes. And so we want to start with I being 1, and then we want to do I minus message marker length. I'm going to call this MML. It'll just make it look prettier. And so we're going to say if length of that, because we should get a collection return, equal to our message marker length, return I plus 1. Okay. So we're just saying, hey, go ahead and unique that set. And if the number of values that we return, the unique values, are equal to our message length, then we know we have the value. So go ahead and return I. We'll return 0 as the default. And then we'll run this function. Let's see here. What did I do wrong? Well, let's make sure. I briefly gazed at the test input, but let's make sure 100%. Why don't we just do this? Okay, so test input's all good. So I is going to be 13. Slice index out of bounds -1. Why am I getting -1? I will be 13 on the first iteration. -14 should be 0. Okay, let's just do this. Oh, let me make sure. Yeah, okay. That file isn't saved. Let me just debug it. Yeah, we're converting between index and counts here. So I'm just going to +1 that. All right, let's figure out what this is. We're just going to call this U. And we'll check the length of U. And we'll re-debug it. 1, 2, 3, 4, 5. 8. So this would be 0 to 13. One, 2, 3, 4. Hmm. 26, 29. Oh no, there's 5. 1, 2, 3, 4, 5. Okay. All right, so we can do one other trick here, which is the expected is 19. So we can add a conditional breakpoint where I equals 18. So this is a really cool feature because this means the test will run and only when I is 18 will it stop here. So unique. The length is 13. Oh, you know what? I think I always mess this up. I think this is supposed to be the length, not the ending index. All right. Sorry, I had to take a brief break there. Work gets in the way from time to time, if you know what I mean. But we're back at it. I took a few minutes just to look up when you're dealing with slices in Go. The way they do this, I think is confusing, but everything is based on your left position. So you want to be where your left position is, plus the count of characters you want, which is kind of what I is, but we have to do +1 because I is an index. So if we want 14 from position 0, we have to do 14. That's why we have to add the +1 here. So this works, and that is tested. And so we're going to go ahead and run. Oh, let's label this correctly. Day 6, part 2. So we can always come back and look at it. It's not fast, but it's not slow. Let's see here. Let's run it and see what happens. Here we go. Done. So what can we do differently? Well, if we wanted to make this more efficient, and perhaps I'll do a refactoring video in the future, but we could go back to this technique, but we'd have to do a for loop on the number of characters. It's obviously not optimal to do an index like this. You would have to kind of walk the tree and then walk the tree and then walk the tree. But if we find a match, since we're dealing with a large string of text input, if we can remember where I put that, one of the things we could do to make this more efficient, because okay, maybe we're doing how many characters is this? 4,095 characters, something like that. That's particularly not super efficient. But what we could do is, and you can kind of see it in this pattern, if we control the value of I, when we exit here, we know that, and we'd have to be a little more verbose maybe with our checks, but we know that if you have a string of, say, A, D, C, B, C, G, right? And X, Y. Let's say we're checking this string, and let's say we were doing something larger, like 14 characters. Maybe with 4, it doesn't matter as much. But we could say that if we're here and there's an overlap on C, we actually don't have to move the index to here forward and check. We can actually start the index here. So that's just something I'm thinking about for optimizing this. We can make this a lot more optimal. Really, if you're really trying advent of code, which I'm not, and as you can see, I can solve the problems, but not particularly fast. If you're going for speed, you really, in most cases, you won't worry so much about optimum execution. However, I do know from doing last year's advent of code, you do run into some problems that get to a scale of how do I do this at speed. So even though I created something here that works by calling the unique function on everything and then just checking the speed, I think we could do some enhancements with changing the index position and changing which character we're moving to, as opposed to just testing each individual segment. For 4 characters, I think this is probably just optimal enough. But for 14 characters, or maybe anything over 10, doing this unique operation over and over and over again is a lot of wasted cycle. So I think we can skip a bunch of checks if we were to take a more index comparison approach to it. So, but obviously this scales too, because every character has to be checked as opposed to uniquing it. So I'd be interested to do some benchmarks. So maybe I'm actually wrong. Maybe the unique is the more optimal solution for larger strings, in which case, yeah, we can benchmark it at some point in the future. But that's all I have for now. This is day 6. We'll see you again in the future. Please like and subscribe. All right, bye.